A barbecue grill appears elemental. Metal walls, a grate suspended above heat, a lid that lowers over food. It resembles a container for fire. But the modern grill is not about fire alone. It is about managing combustion, circulation, and human unpredictability. Before grills, there were open fires. Cooking over an open flame is ancient. Meat suspended on sticks, food placed on stones near embers. Heat rose unpredictably. Wind influenced direction. Flames flared without warning. Open fire cooking works, but it demands constant attention. The core problem was inconsistency. Flames are volatile. They burn hotter when oxygen increases. They surge when fat drips. They fade when fuel shifts. To cook evenly, early cooks had to manipulate wood placement, distance from flame, and timing manually. The first significant improvement was separation. Elevating food above coals reduced direct contact with flame. Metal grates emerged as stable platforms. This allowed heat to reach food indirectly while fat dripped away. The grate introduced structure. It created distance between combustion and cooking. The aha moment begins here. The grill is not about fire intensity. It is about fire moderation. The modern grill's body encloses this moderated environment. Consider the classic charcoal kettle grill. Its bowl is rounded, not flat. That curvature is not stylistic. When charcoal burns, it consumes oxygen and produces rising hot air. In an open fire, hot air escapes immediately upward, carrying heat away. In a bowl-shaped grill, rising air curves along the interior walls. With a lid in place, that air circulates back downward before escaping through vents. This creates convection. The grill transforms direct heat into circulating heat. The domed lid enhances this effect. A flat lid would create sharp airflow disruption. A dome allows smooth circulation, reducing hotspots and distributing heat more evenly. Heat rises, strikes the dome, spreads outward, and falls around the food. The grill becomes an oven. This dual nature, direct flame below, convection above, defines modern grilling. Airflow control is the hidden architecture. Vents at the bottom regulate oxygen intake. More oxygen means hotter combustion. Less oxygen lowers temperature. Top vents allow controlled exhaust. The balance between intake and exhaust determines internal temperature stability. Without vents, charcoal would burn too fast or suffocate unpredictably. The grill's shape enables controlled combustion. Gas grills solve similar problems differently. Instead of charcoal, burners produce flame directly from gas jets. Heat diffusers, metal plates above burners, spread flame energy evenly across the cooking surface. These diffusers also prevent flare-ups by blocking direct contact between dripping fat and open flame. Again, separation is key. The grill's structure isolates food from volatile fire while maintaining sufficient heat transfer. The grate itself introduces design trade-offs. Spacing between bars must be narrow enough to support food without falling through, yet wide enough to allow heat and smoke contact. Thicker grates retain heat longer, creating pronounced sear marks. Thinner grates heat quickly but cool faster when food is placed on them. Material choice matters. Cast iron retains heat and produces strong searing but requires maintenance to prevent rust. Stainless steel resists corrosion but may not retain heat as effectively. These decisions reflect intended usage patterns. Casual backyard cooks may prefer ease of cleaning. Enthusiasts may prioritize sear quality. The height of the grate relative to the heat source is also deliberate. Too close and food burns. Too far and searing weakens. Adjustable grates allow users to modify this distance, but many grills fix it at an optimal average. Human behavior influences the lid as much as physics. Grilling often involves social interaction. The cook may step away briefly. The lid reduces vulnerability to sudden flare-ups and temperature drops. Closing the lid stabilizes the environment. The grill becomes forgiving. The realization deepens when you understand that grills manage unpredictability. Wind, fuel variation, moisture content in charcoal all introduce instability. The enclosure buffers against these variables. The grill is not merely a container, it is a thermal regulator. Its metal body absorbs heat, reducing fluctuations. Its vents modulate combustion. Its dome redistributes energy. Before grills, cooking over fire required skill and constant monitoring. The grill reduced skill requirements by introducing structural control. It democratized outdoor cooking. The rounded kettle design became iconic because it balanced efficiency, durability, and airflow symmetry. Square grills exist, but airflow in corners can stagnate. Rounded shapes eliminate corners, improving circulation and reducing uneven heating. This is subtle but important. Even small differences in airflow alter cooking performance. The drip tray beneath gas grills solves another problem: cleanup and safety. Accumulated grease can ignite unpredictably. A tray channels drippings away from heat sources. The grill anticipates fat release. Again, invisible design compensates for human habits. People grill fatty meats, fat drips, flames flare. The grill mitigates. Even the lid handle reflects consideration. It must remain cool despite internal heat. Insulated materials prevent burns. The handle is elevated to reduce heat transfer. Temperature gauges built into lids offer feedback. Though not perfectly precise, they provide reference points, reducing guesswork. The grill's form evolved through iteration. Early metal boxes without lids provided structure but limited control. The addition of domed lids transformed grills into hybrid devices, part open fire, part oven. The aha moment often arrives when you realize that grilling is not about direct flame at all. It is about controlled airflow around radiant heat. The fire is a heat source. The grill is a heat manager. Its rounded body shapes combustion. Its lid shapes convection. Its vents shape oxygen supply. Every curve and opening participates in thermal choreography. Invisible design thrives in controlled environments. The grill's form persists because it reached equilibrium between openness and enclosure. Too open, and it reverts to unpredictable flame. Too enclosed, and it becomes inefficient or suffocates combustion. The balance creates a stable yet responsive system. When you lift the lid and see food marked with parallel grill lines, you are witnessing the product of controlled radiant heat and airflow. Not chaos. The grill looks primitive because fire is ancient, but its current shape reflects engineering layered atop tradition. It exists in its familiar bowl and lid form because that geometry manages the physics of combustion better than alternatives. The grill is not designed to hold fire, it is designed to discipline it. And perhaps that is the quiet lesson of its form. Invisible design does not eliminate chaos, it contains it. A curved metal shell turning open flame into controlled heat. A lid transforming unpredictability into repeatability. A tool that allows gathering around fire without surrendering to it.